So if we look at the math tip sheet that I gave you, the most important thing is you have to show all your work. When me and the other readers grade your papers, we can't give you credit unless you show how you got to your answer. So show your formulas, and you won't have a calculator, so don't hide your scratch work like you're embarrassed of it. Just show it so we can see it. Operation hints, you will be given like a large paragraph, and it'll be kind of intimidating. So look for is. Is means equals, and so you can sometimes even set up like a formula, and you can read it like a sentence and fill in equals where you see is. Of means multiply, and a lot of times this will come through where you're doing percentages. It'll say what is 20% of 120, and you can just multiply those out. Per means divide. And so a lot of times, like if we're talking about, I don't know, 20 miles per hour, that's actually, written like a fraction. And that's going to be important here in a second when we do conversions. You can flip this upside down and say 1 hour is 20 miles or 20 miles is an hour. Show all your units. The units, see like how I've done here with miles per hour. Show those, and those will keep you from actually getting tripped up, because you're going to do dimensional analysis, which is this way of canceling out your units as you multiply. If you're not showing your units, you won't know where you mess up. Make sure your answers make sense. If we're talking about how much a light bill or a water bill is, or how many people are in a country, if we're doing a calculation for the people in China that have a bicycle, and you get, 37 billion, well, there's only 7 billion people on Earth, so that's probably not right. So as you're going through this, I like to do mental math first, kind of eyeball it, and then kind of estimate. And then when I'm done, I can check my answer that way. I would encourage you to do that. I've seen people get, $1,000 per kilowatt hour on a light bill. That doesn't make sense. So your answer should make sense. Simple conversion factors. The AP people will expect you to know 365 days in a year. 24 hours in a day, and that seems maybe insulting, but I've seen people that don't know that. There's 366 days in a year this year, but normally 365. You need to know that the population of the United States, it's over 300 billion now, but that number will work. I think it's closer to 315, 320. And then it's also really handy to know that there are 3,600 seconds in an hour, because 60 times 60, 60 minutes and 60 seconds is 3,600. And the population of the world is 7 billion. Notice here that I've went ahead and I've rewritten billion as 7 times 10 to the 9th. You have to know some of these things. When you see billion, you ought to automatically go 10 to the 9th, like that quick. You just have to know that. So billion is 10 to the 9th. Million is 10 to the 6th. Billion. Million. 1,000 is 10 to the 3rd. These have to be memorized. They just have to be. Because here very shortly, you're going to start working on population problems. And it's going to say there's 1.2 billion people in China. You can either write down 9 zeros or write down times 10 to the 9th. What do you think I want you to do? Right. So scientific notation is the answer to all your problems. The other ones over here aren't quite as important. These are a must. And notice that this capital M is million, this little k is 1,000. So anytime you see that little k, you can actually substitute 10 to the 3rd. You see that capital M, you can substitute 10 to the 6th. Let's see. Number 7 is not very important with that, or 8. 9 is not super important today. Number 10 will come up later. Number 11. Some of you guys have not had this taught to you in chemistry yet. So unit conversion problems. Let me just read you this problem, and I'll show you how to do it. So I'm not even going to read that first sentence. So let's just say you were given there's 4 oranges per box. Oranges are $5 per box, and you're asked to calculate the cost of 420 oranges. And so up here it says start with a unit conversion. Whose unit has nobody. Some of you are like following me, and some of you don't know what I mean. So let me show you this. Let's just do a simple distance problem. Let's say that I wanted to go from 5 miles to something like inches, okay? Now, can you think of some helpful conversions that would be good for going from miles to inches? I'm going to call on somebody. Miles to inches. Alex?
Maybe going from inches into feet.
Yeah, so what would that be?
12.
1 foot is
12 inches.
Sure. And does anybody in here know how many feet are in a mile? I know.
Like,
That's exactly right. So 1 mile is 5,280 feet. Now, that means, so this is the thing right here. That means that 1 foot is 12 inches, or for every 1 foot, that 12 inches. So we can write these things that are equal. We can write them as a fraction. Okay. This down here, I have 1 mile. Oh, wow. I just wrote that word backwards. 1 mile is 5,280 feet. And these things equal each other. So really, this fraction, what does this fraction really equal if I wanted to give it a numerical value?
1.
1. This equals 1. This equals 1. So can I also write this upside down, like 12 inches over 1 foot, 12 inches per foot? See how this is per? That's where that per comes in. There's 12 inches per foot. Or I can write there's 5,280 feet per mile. And per means divide. Fractions are divided, okay? Now, I said at the beginning that I wanted to take 5 miles and go to inches. Does 5 miles, does it have a buddy? Is it equal to something? That's how you know where to start. And so what I'm going to do is I'm going to write 5 miles over 1. So you start with the value in the problem that isn't equal to something else, that doesn't have a friend. It's all alone. 5 miles isn't equal to anything. And I'm going to multiply. Now, I need to go to inches. I want miles to be on the bottom. Have y'all that have chemistry before, is this like ringing a bell for you? So I want to go to inches. So what I'm going to do is I'm going to put 1 mile on the bottom. So whatever you're trying to cancel is going to go to the fraction, the bottom of the fraction, the denominator of the next fraction. So 5,280 feet, and my miles cancel. All right. Now I'm going to go ahead. Feet are going to be on the bottom here. 1 foot is 12 inches. When you have what you want in the top right-hand corner, then you know you're done. If everything cancels and you have what you want in the top right-hand corner, then you know you're done. The only reason you can do this, in math class, can you just take a value and start multiplying it by a mess and just call it a day? You can't do that. The only reason this works is because I just took 5 and I multiplied it by 1 and I multiplied it by 1 and I really still have 5. If your fractions are not equal, if this doesn't equal this, then you're doing it wrong. What people will do, for example, is, y'all okay with this? What people will do sometimes when we're doing metric stuff, don't ask me how many times to move the decimal on something metric. I won't tell you. But sometimes, let's say that if we had to go from 37 kilometers to meters, what people will do is they'll do this. They'll say 1,000. That should ring your bell, like your head is 1,000. They'll say 1,000 kilometers is 1 meter. You can't do this because 1 meter does not equal, this is 1,000 meters. This is a million. 1,000 times 1,000 is a million. So these don't equal. So you can't do this. What you can do is you can go 37 kilometers and then make sure that these are equal. When you see K, you should say 1 times 10 to the third. Like that should be like an instant thing for you. 1 times 10 to the third. 1,000 meters equals 1,000 meters. This equals 1. I can do this now. So check yourself. You don't have a calculator. It's important that you do some checking before you start having to crank all this out by hand. Okay? So you're going to set up some fractions. They may have 4 or 5 of these long and that have numbers in the billions. And so it's worth your time to check. Going back to the question that was on the little math tip sheet, it was asking about how many 420 oranges, how much that would be, right? So go ahead and figure out, see if you can do that math problem on your paper. I'm going to do it on the board. Don't look up here, and we'll talk about it in a minute. Alex, actually, I have one right here. So don't look up here. You try to do it on your own. I'm going to work it up here silently. It was number 11. Sorry, I messed my decimal up. I was talking to Miss Robeson. There you go. Okay, so don't look up here until you have yours kind of situated. Yes, ma'am.
You have to show that step in the middle.
This?
420 times 5 and 4. No, that
This?
one right there. Yeah, do you have to show that, or can you just work it out and do equals $525 at the end and calculate?
You don't have a calculator. Can you do all this? No, you have to show this. I'm being very serious when I say on the AP exam you have to show 2 plus 2. I'm not kidding. I'm dead serious.
I mean, I know you have to work it
No,
out.
no, no. You have to show, yes, you have to show everything I've shown. Yes. I do this every summer. Yes, you have to show that. Yes. And it'll keep you from messing up. And so sometimes when we are grading your test, if we can follow your work, you may get 1 point and then it carries over if you can go back and see kind of where they made an error, but then they used the wrong answer correctly in the next step. But you do have to show your work. And, you know, you're going to be stressed for time. You're going to have to answer 4 questions in 90 minutes, and they're going to have 4 or 5 parts, 6 parts each. You need to show your work. You need to show where you multiply, where you divide. It's non-negotiable. All right, so when you read the problem, it said there was 1 box with 4 oranges. There's $5 a box. And you wanted to know the cost of 420 oranges. 420 oranges was the only thing in the problem that did not have something paired with it. It was all alone. So you start with it, and then you want to set up your problem so that what you're canceling is on the bottom of the next fraction and what's on the bottom of the next fraction. And then I multiplied, I got 2,100, and then I divided by 4. Miss Robeson came in and was talking to me while I was working this out, so if you saw me, it was kind of rough, but it ends up being $525, and that's how much 420 oranges would be. These numbers, 420 oranges and $525, those are equal. They're the same, right? Because all I did was multiply by 1 and multiply by 1. $525 is 420 oranges. And if I needed to, I could actually make that a fraction, a conversion factor. These are called conversion factors. You guys that haven't had chemistry yet, or maybe it's been a while, do you feel okay with this? You get that kind of the gist of it? If you just keep in mind you need to start with something over 1, and every fraction needs to equal 1, and when you're done, what you want is in the top right-hand corner, you'll be all right. All right, so there are, yes ma'am?
I'm sorry. I didn't start off mine like that, where I actually wrote out 1 box over 4 oranges. I just automatically did 4 over 420, and then I cross multiplied with the 5 over 1. Is that okay to do, or do you have to show this?
There will be some problems where you won't be able to get, this is super simple. They get really nasty. And so I think even if it's easy at this point, if you can tell they're wanting you to convert units, I would practice this, especially if you're a year or 2 out from chemistry and it's blurry in your mind. So anyway, going back to our little sheet, we need to look at some formulas for population. I think I would rather us figure out the formulas for population, and I'll go back and show you that in a minute. All right, so you're going to talk together in your groups. For population growth, this is the first formula we're going to use. We have birth rate, births, and deaths. Using only these 2 things and 1 mathematical operation, talk with your group and figure out what the growth rate for a country might be. Only using these 2 words and 1 mathematical, 1 mathematical operation. Very simple. Talk with people. All right. Let's see. Elaine, what was the formula if we wanted to do growth rate?
Births minus deaths?
Yeah, so it would be births minus deaths. And sometimes it will actually be this easy. They'll give you the crude birth rate and the crude death rate, and that means per 1,000. And then the crude growth rate would just be births minus deaths. Very simple. So let's make that B, make that D. Now, sometimes we have, in the mix, we have immigration with an E. And remember, immigration with an E is like exiting. I'm sure your social studies teachers told you that. And we have immigration with an I. So, in your groups, we're going to have to add in a little bit more math to this. But just using 4 basic math functions, see if you can come up with a formula for growth rate with births, deaths, immigration, and immigration. See if you can figure it out.
Yeah. B minus D and add I minus D. So either one. I'm pretty sure that's what we first way
So births you start introducing immigration to it's B
just add
immigration
to the births and add immigration. Because they do the same thing.
Hello. Chelsea, what did you guys get? Off the top of your head, births would go with E immigration or I immigration? With an I, right? Because those are people coming in. So what do you think I should do with this value and births? What should those values get? What should happen to those? They should totally be added, right? So births plus immigration minus still my deaths plus immigration. Alright? Now, this works when they give you crude values. Crude means per thousand. Sometimes they don't do this. Now, let's say they just gave you something like a country had 60,000 births, 40,000 immigrants, 20,000 people died, and 10,000 people immigrated with an E. And they wanted you to find the growth rate. If I just plug those numbers in here, I would get an answer like 12,000. Would that be a rate? No. So talk to the group. Tell me what you think probably needs to go on the bottom of that fraction. Think about it. Think about percentage and what the definition of percentage is. So if I don't have crude rates, if I have just absolute numbers, it's not a crude rate. So they just tell me the numbers of people that come and go. Not crude rates, just numbers. What would I do? Caleb, what do you think? When I do percentage, do you know the formula for percentage? Want to help her out, Kara?
It's like part of all.
Right, and so if I was dealing with population, and this is the part, this is like the kicker right here, right? If this is the part of people that changed, right? And percentage is part divided by whole, what does the bottom need to be, everybody? That's right. So, anytime, so that's the part that changed. I'm going to erase this to give myself some room. Anytime I'm dealing with just absolute numbers, like I said, if they told you how many millions of people were born or thousands, told you how many immigrated and emigrated, and they'll give you the total, this is what you do. And then, because it is basically a percentage, that's the part that changed, divided by the whole thing, you will multiply by 100. So that's how to do growth rate. Now, let's just say I don't have immigration in here. You just do the same formula, and you don't worry about it. Sometimes they won't give you immigration information. You just births minus deaths over total. Just take what they gave you and work with it. If you're lucky, sometimes they'll give you crude birth and death rates, and that's really great. Like crude birth rate might be 16. If your crude birth rate is 16, and your crude death is 10. When you see the word crude, you know that means per thousand, which is great. I love it. On your warm up, I asked you guys to tell me if I had a number per thousand and I wanted to convert it to 100, what to do. So let me show you something. If I wanted to find the growth rate here, I would still do crude birth rate. CBR means crude birth rate. Crude death rate. So 16 minus 10. So that's 6 per thousand. Every once in a while, though, they'll ask you to give that as a percentage or as a rate. Can we change this to percentage pretty quick? Let's talk about the word percent. Per cent means 100. That's why there's 100 cents in a dollar. Per cent means per 100. This is per thousand. So I saw a couple people get this down. If I wanted to go from 6 per thousand to 6 per 100, Morgan, what would I do?
You move the decimal to the left.
Yeah, so you move the decimal to the left, and so it's going to be 0.6 per 100. But really what you're doing, I don't want to just say move the decimal. Let me show you this. I'm going to erase it and show it to you. If I have 6 per thousand and x per 100, right, you're going to end up cross-multiplying and dividing, and you do get 0.6. Or you can just think about it as a fraction. If you wanted the bottom of the fraction, When you're working with fractions, y'all know if you do the same thing to the top and bottom, it's fine, right? But want the bottom to be 100, I'm going to divide by 10. And so I have to divide by 10 to the top. That's probably the easiest way to think your way through it. Now, by definition, percent means per 100. This is a percent, 0.6%. Percent means per 100. This is per 100. You don't have to multiply by 100. That's the definition of percent. Parts out of 100. That's all the math. You ready to get started? All right, so all the little population formulas, they're on your sheet. I will show them to you real quick. Please make sure you're using scientific notation for all this. Please, please, please. What I was just showing you, oh, there was one more I didn't show you. Per capita and Rule 70, but annual rate of change. Here is your crude birth rate and immigration, crude death rate, and immigration. I'm going to talk about 16 and 17 real quick, actually, and 18. There's a lot of math to this, sorry. I thought I was done. I was like, yeah, I did dimensional analysis. No. All right. Couple more things. Thank you, Alex. You're like, yeah, Miss Spring's done talking. Oh, I know what the problem is. Here, I'll help you. Ready? Do it now.
All right.
Appreciate it. So if we go back, do y'all know the formula for density? Think about it. I'm going to call on somebody. Density is, Abigail, do you know the formula for density?
Is it mass over volume?
It is, right? Because you love density. You've seen this before? Yeah. So anyway, population density is a thing, but we're not going to weigh people. That's not a thing. So population density equals people. That's the quantity that we're measuring. And people don't take up a volume. Like, we don't measure the volume that people take up. So we're going to measure the land area. So this is going to be land area. And it's going to be usually in square kilometers. Notice it's not cubed kilometers because that would be volume. So squared is a area of unit of the area. So that's population density. Real simple. Per capita, I think about people wearing hats. Per capita is per person, so per hat. Okay, per capita is per person. And then the last one, real quick, the rule of 70. Doesn't that sound fancy? Sounds like something in history, right? So this is like the easiest thing, but you see it 2 or 3 times on each AP exam. They use it at least once, but I think I've seen it twice on some of them. So 70 divided by the growth rate. Let's say that the growth rate of a country was 2%. You don't move the decimal. You don't move the decimal. You just go 70 divided by 2. And this is the doubling time. So the rule of 70 will give you the doubling time in years. And the reason this is a thing is mathematically, when you work this out with a calculator, y'all know when you're in math class and you had to have like the E button and it's raised to some powers to find like interest rates and growth for money. You don't get a calculator, do you? So this is the only way that you can do anything to predict future populations. It's the only way to do it. So if you just take 70, that's the rule of 70. You take 70, you divide it by the growth rate. In this case, if the growth rate was 2%, you do not move the decimal. This is the only time where you have a percentage and you don't move the decimal. You just go 70 divided by 2, 35 years. If the growth rate was 1, 70 divided by 1, it's going to double every 70 years. If it was, 3.5, then 70 divided by 3.5 would be 20 years. Okay? So you just take 70 and divide it by the growth rate. And that is all the math, I promise. So those are in your sheet. I gave you a sheet because it's a lot. But go ahead and get started on your math practice. Notice that I told you guys that you could use your calculator on the, is that the top? Calculator on even or odd? Even. Okay, so even you can use your calculators. You have to show the formula. You have to show your units. You have to show your work. Not kidding. Even if you can use your calculator on a question, you still have to show your work. Thank you.